Hello students, we are solving the IB Math AA AGL past papers and currently we are solving the IB Math AA AGL November 2022 paper 1 past paper. Today we will be solving the question number 6 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 6. The maximum mark is 6. Events A and B are such that probability of event A occurring is 0.3 and probability of event B occurring is 0.8. Subpart A says, determine the value of probability of A intersection B in the case where events A and B are independent. It contains just a single mark. Okay. So we know the formula for independent events. It will be the probability of A intersection B. It is given in your formula booklet. I'm just writing the formula over here. Probability of P intersection B is equal to P of A times P of B for independent events. Okay. So P of A is 0.3 and P of B is 0.8. Therefore, probability of PA intersection B is equal to 3 times 8 is 24 and divided by 100. So it is 0.24. Okay. This is the answer for the subpart A. Now coming to subpart B. Determine the minimum possible value of P of A intersection B. Now, whenever we are reading that they are asking for the minimum possible value, we should be understanding that A and B are no more independent events, because if they had been independent events, we would not have had the minimum possible value or the maximum possible value of P of A intersection B. We would have had only a single value of P of A intersection B, which is 0.24 that we have found in the Sapati. Okay. So, A and B are not independent events. So what can be the minimum possible value? Okay. How to find? And see, I am seeing these because I am just placing myself in the seat of a student. Okay. So when a student sees this, when a student reads this question, how will he or she be trying to answer this, to attempt this question? Can the student apply some formula? Is there any formula which will be telling you the minimum possible value of P of A intersection B? How many formulas do we know that have this P of A intersection B part? The first one is this: for independent events, P of A intersection B is P of A times P of B. I have used that. And now they are no more independent events, so we cannot use that formula anymore. Another formula that we have which contains the P of A intersection B part is the conditional probability formula, but over here there is no condition given. So what can we take? Which formula can we take? This can be proved using a Venn diagram or using the algebraic approach. I'm going for the algebraic approach. So which formula should we be taking? The only formula that I can think of which contains this P of E intersection B part is the formula for P of E union B. Let us go for that. Okay. So, what is P of A union B? P of A plus P of B minus P of A intersection B. You can write the P of A union B first as well on the left side. This should be equal to P of A union B. Okay. And in place of P of A, I am writing the value, which is 0.3. In place of P of B, I am writing its value, which is 0.8. This part has to be found out. So I'm keeping it as it is. And what is this value of P of A union B? We do not know the value of of A union B, but what we know is, since it is a probability, its value should be between 0 and 1. The lowest possible value for any probability is 0, and the highest or the maximum possible value for any probability is 1. So this is no exception. This is also a probability. So probability of A union B will also be, the maximum value will be equal to 1. So the left hand side should be having a value less than or equal to 1. Okay. Because if this probability is equal to 1, so this one will be equal to 1. If it is less than 1, so this will be less than 1. Okay, so I have written the probability of 0.3 plus 0.8 minus the probability of A intersection B is less than or equal to 1. Okay, so that means I'm taking this P of A intersection B to the right side, and I'm bringing this 1 to this side. Okay. So what I am having is 0.3 plus 0.8 is 1.1. So 1.1 and minus 1. And I am taking this part to the right side. So it is probability of A intersection B. Okay. So what is this? This can be written as P of A intersection B. See, this open side is facing the P of A intersection B. So this was written on the right side. Now I am writing this on the left side of the inequality. But you have to just see, I know you are EHL students, so I don't have to say these things at this stage. But even then, I'm just reminding you that you have to check which side is the open side. You have to keep that same side. The open side should be facing the same expression. This should be greater than or equal to 1.1 minus 1 is 0.1. Okay. So the probability of A intersection B is greater than or equal to 0.1. Therefore, what will be the minimum possible value? Obviously equal to 0.1, because the other values of P of A intersection B will be more than 0.1. Okay. So therefore, the minimum value possible value of P of A intersection P is equal to 0.1. Okay. Fine. Now we come to the subpart C. Determine the maximum possible value of P of A intersection B, justifying your answer. Okay. So this is the minimum possible value. If I draw the Venn diagram, what happens? For getting the maximum possible value, it is better to draw the Venn diagram. You will not be getting the maximum possible value easily using the formula. Okay. So this may be A, this may be B, and this may be C. This may be A, this may be B, and this may be C. This may be A, this may be B, and this may be C. This may be A, this may be B, and this may be C. This may be C, and this may be D, and this may be E, and this may be F, and this may be G, and this may be H, and this may be I, and this may be J, and this may be K, and this may be L, and this may be M, and this may be N, and this may be O, and this may be P, and this may be Q, and this may be R, and this may be S, and this may be T, and this may be U, and this may be V, and this may be W, and this may be X, and this may be Y, and this may be Z, and this may be D, and this may be E, and this may be F, and this may be G, and this may be H, and this may be I, and this may be J, and this may be K, and this may be L, and this may be M, and this may be N, and this may be O, and this may be P, and this may be Q, and this may be R, and this may be S, and this may be T, and this may be U, and this may be W, and this may be X, and this may be Y, and this may be Z, and this may be D, and this may be E, and this may be F, and and the minimum possible value for this part is 0.1. So P of A was equal to 0.3, so this part is 0.2. And P of B was 0.8, so this part is 0.7. So 0.2 plus 0.1 is 0.3 plus 0.7 is 1. So the probability of this outside part is equal to 0. So this is the condition. This is the minimum value for this part, this region, the A intersection B region. Can we increase the probability of that part? Yes, we can increase. What happens if I change this to 0.2? Instead of 0.1, I am taking 0.2. And I am explaining this. You don't have to draw the stage by stage. So, in place of 0.1, I will be now taking the intersection portions probability as 0.2. This is A and this is B. P of E is 0.3. So this part is 0.2, so this part will be 0.1. And P of B's probability is 0.8, this is 0.2, so this portion will be 0.6. 0.1 plus 0.2 is 0.3 plus 0.6 is 0.9. So now the probability of this outside part will be equal to this. What is this region? It is the probability of A intersection, A prime intersection B prime. Okay. So probability for this, in the previous diagram, the probability of A prime intersection B prime was equal to 0. Now the probability of A prime intersection B prime is equal to 0.1. Now instead of 0.2, because they have asked for the maximum value, I'm just increasing the probability values in steps of 0.1 for that intersection region. Okay, so can we make the probability of that intersection region as 0.3? Let us see. If I have, this is A, this is B, and this part's probability is now 0.3. Okay. So what is this part's probability equal? It is 0 because the probability of E is 0.3 and the whole probability of E is over here. So this part's probability is equal to 0. So, and the probability of this part will be equal to 0.5. Okay. So actually what is the region, this region? If I write, what will I be writing? Which part's probability is equal to 0? This is not asked for in this question, but you should be knowing. You had, in fact, learned these in your IGCSE days, but in case you have forgotten, this part is the intersection of A and B prime. So this is P of A intersection B prime. So this is equal to 0. So what is the probability of this part, which is probability of A prime intersection B prime? It is equal to 0.2. Okay. So I have found the probability of A intersection B as 0.3. I have taken as that as 0.3. I'm just going on increasing the probability of that intersection region. Can I have the probability of that intersection region as 0.4? Let us see. Let us try. 0.4. So what will be the probability of this area? E intersection B prime. This has to be negative 0.1 because the probability of E is 0.3 and probability of E intersection B, if I take this probability as 0.4, probability of E intersection B prime should be equal to negative 0.1, which is not possible. Probability can never be negative. So I cannot have this type of a situation. The maximum value of E probability of E intersection B can be 0.3. I cannot go above that. And how can I draw this? How can I draw a better diagram for this situation? Because this side is equal to 0. So this can be drawn in this form. This is the B and this is the A. Because the whole of E is within B. There is no portion which is outside B. So E is the subset of B. Event A is the subset of event B. So this part is 0.3. This part is 0.5. And this part is 0.2. Okay. So therefore, the maximum possible value of P of A intersection P is equal to 0.3. So this is the answer for this part C. And we have solved the question number 6 completely. Thank you for staying with me till the end. I am Nilanjana Sanyal. I'm an online IB Math ESL and HL level tutor, and I tutor students from both within India and outside India. And I offer both one-on-one and small group online tutoring sessions to my students. And as you are seeing that I am uploading the past paper IB Math HL past paper question solutions in my YouTube channel. In case you are liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And please subscribe to my YouTube channel. It will be motivating me to make more math videos for you because I will be knowing that you are liking my explanations. I am being able to help you. So that will be acting as a motivation for me. So please subscribe to my YouTube channel and we meet again very soon. First of all, before that, in case you have any query, any doubts, please feel free to write to me in the comment section. I will be trying to answer your doubts, clear your doubts as much as possible. Okay? And we will be meeting very soon. In our next session, we will be solving question number 7 of the same paper. So till then, bye.